Welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my grade 9 elite students to the first video of term 1. We are covering today module 6, lesson 1. This is module 6 measurement from your math book, and the lesson that we are doing today is area of quadrilaterals. Today's video is going to be part 1 of it. So let's dive into the video and get to know our learning objectives for today. So in today's video, you are going to understand about the different types of quadrilaterals. You are also going to know the difference and similarity between them, and also find the area of parallelograms, trapezoids or trapezium. So let's dive into the video and see what we are learning today. We call first about the different types of quadrilaterals that you know. So out of all the different types of quadrilaterals, there is a trapezoid, or it has another name, trapezium. Both are same, two different names for the same quadrilateral. Now remember, quadrilateral comes from two words, quad and lateral. Quad means four and lateral means side. So a solid, a closed figure, two-dimensional. So it's a two-dimensional. It has length, breadth. You can find its area. Two-dimensional closed figure having four sides. That's what is a quadrilateral. Now quadrilateral, 1, 2, 3, 4, four sides. So it's a trapezoid, and you see one pair of sides is parallel. The other two are non-parallel, so that's a trapezoid for you. Rectangle, opposite sides are equal. So this is equal to this and this is equal to this. It is again closed and four-sided. Square, when all sides are equal, very simple. So a rectangle becomes a square if you make all the sides equal. And finally a rhombus, which is another kind of parallelogram. Now what is this parallelogram? Parallelogram comes from parallel. So if it has opposite sides parallel, that's what is called a parallelogram. And a rhombus has all sides equal also. So if you take a parallelogram and you make all of its sides equal, what you get is a rhombus. So these are all the kind of quadrilaterals that you should know, and let's get to know more about them. Here I have given you a list of properties of the quadrilateral so that you don't get confused. So when it's a parallelogram, it has opposite sides parallel, opposite sides equal, and opposite angles are also equal. So these three properties are going to be true. If it is a square, all angles are 90 degree and all sides are equal. If it is a rectangle, opposite sides are parallel, they are equal because it's like a parallelogram, but all angles are as well 90. So if you look at the corners, all these corners are 90 degree for a square and for a rectangle. So all angles are equal to 90. Then comes rhombus, which is like a parallelogram with all sides equal and opposite angles equal as well. Last is trapezium or trapezoid. So both, as I told you, are same, two different names for the same thing. So here you have exactly one pair of parallel sides. You can see only this is parallel to this. These two are not parallel, and they have sides that are not equal in length. You don't know anything about that. And as you would see, there are different types of trapezoids or trapezium. Some are isosceles, some have unequal sides. All of that you'll get to know in this lesson in great detail. Now let's come to our first key concept, our formula sheet. So here you have a parallelogram given. As you can see, opposite sides are equal and parallel. You have a height of the parallelogram and you have a base of the parallelogram. Both of them are at a 90-degree angle. So if in the question you are given the length of the base B and the height H, then area of parallelogram. So this is a short form of writing parallelogram. You make parallel lines and put gram is equal to the product. Product means multiplication of base with height. That's the formula you need to learn and remember, and we'll use it now to solve some problem. Okay, so let's solve a question using trigonometry to find the area of parallelogram. So for area of parallelogram, the formula is base multiplied with height. Is the base given to you? Yes, it is 19 because this is, it is 17, sorry, because this is 17. So this will also whole length be 17 as it's a parallelogram, opposite sides are equal. But what about the height? The height h is not given to you. So you need h in order to find it. Now to get to this h, because h is not given, but you are given it's a 45 angle here. So this is 90. So this becomes 45. So this is a 45, 45, 90. So 45, 45, 90 is a special triangle. You've studied about it in trigonometry, so we are going to use that property to find height of the parallelogram. Now recall from the formula that if the measure of the opposite leg opposite to 45 is h, which you can see opposite to 45 is h, then the measure of the length adjacent is also h. That means this adjacent and this one has equal length. That's the formula sheet. That's the special triangle property. So h is going to be 9. Now that you have your h, area is equal to base times h. Base is 17, height is 9. So you multiply, unit is yard square. So that would give you your area. Is our solution. This is an answer key. So if you see in the question, we did two steps, step 1 and step 2. In step 1, we used the property of special triangles to get our h, and in step 2, you multiplied both of them to get 153 yard square as the area. Let's do one more question on parallelogram. So here you have to find the area of the parallelogram. You're already given the base. So if this is 21, this is also 21. The only thing you need is the height. Height is not given to you. So for that, we will use Pythagoras theorem. ABC is a right angle triangle. I'll just draw it one more time here for you. So this point is BCA. You're only given 17 centimeter as your hypotenuse. You don't know the measure of other sides. So if it is a right angle triangle, you are given two sides. This is 8, this is 17. You can find the third side, which is the height here, by using Pythagoras theorem. So hypotenuse square is equal to opposite square plus adjacent square. So simplify. What is 17 square? It is 289. H square as it is. This is 64. So your h square would be 289 minus 64. Let's do that calculation. This comes out to be 225 centimeter square. So your hypotenuse is square root of this. So it will come out to be 15 centimeters. So now that you have your height, your area would be base multiplied with height. Let's do that calculation. Base is given to be 21, height is given to be 15. Unit is centimeter square. So when you do that, 21 multiplied with 15, what you get is 315. So your answer would be definitely A. So that's how a multiple choice question, the one that you can get in your ministry exam, is to be solved using trigonometry, using Pythagoras theorem. Let's now move to the second learning objective, where we are looking at a trapezoid or a trapezium. So as you can see, it has one exact pair of parallel sides. Height is outside. So a trapezoid is a quadrilateral where exactly one pair of parallel sides are possible. We've already discussed. And the height of the trapezoid is the perpendicular. Perpendicular means 90-degree distance between bases. One base is here, one base is here. The perpendicular distance outside lying in the trapezoid at a 90-degree angle perpendicular to the base is height. The area of the parallelogram is the product of height and sum of the two bases. So the area of one trapezoid is half of the area of parallelogram. So what will be the formula? Area of trapezoid or trapezium will be 1 by 2 height times b1 plus b2. So you are taking sum of the two bases. So if this is say b1, this is b2, then you add them and you multiply with height, divide by 2. That's your area of trapezoid. Word problem. So this girl April is sewing a poncho based on a pattern she designed. As you see, her poncho is in the shape of a trapezoid. Now she wants to find the area of her poncho using trapezoid, and if the fabric she wants to buy is this much dollars per square foot, how much money should she pay? So let's find first area of trapezoid, because once you get area, finding the cost will not be difficult. So formula is half h times b1 plus b2. What is the height? As you can see, 2 feet. What is the first base? 1.5. What is the second base? 2.5. So just add them and put them. So 1 by 2 times 2 times. So if you add 1.5 and 2.5, you get 4. Now you cancel the common terms. 2 goes with 2. You are only left with 4. So what is the final area? 4 square feet. Now for 1 square foot, she is spending how much money? $1.75. So for 4 square feet, how much she is going to spend? Just multiply both of them and you will get the cost in dollars. So 1.75 multiplied with 4 would give you $7. So which one is your answer? B. That's how you solve a multiple choice problem on area of trapezoid. Let's do another word problem. Here, Miguel wants to cover the top of the desk with the butcher paper before working on a project for his art class. If one sheet of butcher paper covers 1 square meter of workspace, how many sheets will Miguel need? Okay, so it's given that one sheet covers 1 square meter of workspace. So one sheet is 1 square meters of workspace. So how many sheets will cover for the area? So you need to first find the area of the table. So that's in the shape of a trapezoid. I hope you can see. So h times b1 plus b2 divided by 2. How much is the height? Height is given 0.9 meters. One base is 1.2, another is 1.8. So add them both. This becomes 1 by 2 times 0.9 times. This is 3 meters. So when you do that calculation, what you get is 1.35 meters square. So for one sheet, you got this much area. How many sheets will be required for the area? So now you can replace the area with 1.35 meters square, multiply them both. So because it is 1.35, little more than 2, so can we say she will require 2 sheets? She'll have to cut the second sheet into half and then use it for covering. So the area is 1.35 square meters and she'll need at least 2 sheets of butcher paper, because that sheet, the second sheet, would be used only for covering 0.35 meters square area. Now let's do a very interesting word problem that is there on area of trapezoid. So here you can see the two bases are given to you. So B1 is 2 centimeter, B2 is 4 centimeter, but you are not given any height. So we are first going to divide this into the height form. So you put the perpendiculars straight so that you know this is 90, 90. So the total is 4 centimeters. So can we say this one will be 2 centimeter and this one will be equal 1 centimeter, 1 centimeter. Now you need the height. Both heights are going to be equal because it's an isosceles trapezium. So let's do A, B, C, D, E, F. Now, can I say the area of the trapezoid is the area of, you have just done what? You have broken them into equal parts. So one is a right triangle, one is a square, uh, one is a rectangle, so sorry, and then the next one is again a right triangle. So area of this triangle and this triangle will be same. So we can write area of trapezoid is equal to area of triangle ACD plus area of rectangle ABDE plus area of triangle BEF. Now area of these two triangles is equal, so 2 times area of triangle ACD plus area of rectangle ABD. Okay, now let's find this height. Now for this height, I need the right triangle, I need trigonometry, I need Pythagoras theorem. So this is the triangle. I'm going to draw a rough diagram here, 3, 1, H. So we can use 90-degree, we can use Pythagoras theorem. So 3 square is H square plus 1 square. So this is 9 minus 1 equal to H square. So 8 is equal to H. So H is square root of 8. Now, square root of 8 you can calculate on your calculators. So it will come out to be 2.828 roughly. 2.828. Okay, and now we'll use the formula. So area of a triangle is 1 by 2, base is 1 times height, which is 2.828, plus area of the rectangle would be length times breadth, so that is 2 times the height. Okay, now this will simplify. So you will get 2.828, 1 plus 2. So this is 3 multiplied by 2.28. Unit is centimeter square. So roughly this comes out to be 4.898 centimeter square. So that's your answer for this question. Now comes your exit sheet. So I want you to try this question yourself and comment in the below of the video with your answer. We'll check your answer, and that's all for today's session. Coming up next on my channel is part 2 of today's video. So module 6, lesson 1, area of quadrilaterals. We are going to watch part 2 of it, and we'll get to know more about this lesson. So make sure you subscribe to the channel, give the video a thumbs up if you liked it, share it with your friends, and don't forget to press the bell icon so that you don't miss any videos which are upcoming from my side. Until then, this is Mr. Chika signing off from today's session. See you in my next video. Bye, students.